So you learned about this constructor pattern here, where we create this utility function that builds such a struct value. This can be useful since you now only have to call this function to quickly get such a struct, but it can also offer more advantages than just that. For example, you could now also add validation in there to ensure that any data that ends up in your struct meets certain requirements. And when using such a constructor function, you don't have to repeat those validation steps multiple times in your code every time you create such a struct somewhere, but you instead have them in one central place that's always executed when you create a new user. And for example, here we could add a if check to check if the first name is equal to an empty string maybe, or if the last name is equal to an empty string. And both values are maybe unacceptable in this application, even though we reset it later. But when we create a user, we could require that both values are set. And the same could be true for the birth date, where we also don't want that it's empty. So we could have all these checks here and check if first name, last name, or birth date are empty strings. And if that is the case, we might not want to return this user struct. We might not want to create one in the first place. Instead, we might want to return an error. Therefore, this new user function should now not just return this pointer to a user struct, but instead also an error value. And here inside of this if block, we can therefore, if we have an error, return the nil as a value for this user struct here. So for this user struct pointer in this case. And then as a second value, you can create your error. Here again with the errors package maybe to create a new error with an error message that could say first name, last name, and birth date are required. Something like this. Of course, here where we do return a user, because we do have a first name, last name, and birth date, we now also have to return a second value for that error value here. And therefore we have to add a comma here and return nil as a value for the error. And with that, we added extra validation to this constructor, and we therefore made this constructor even more useful. Now we can go to the place where we create this user and also get this error, and then check if error is not equal to nil, which means that creating this user failed. And here I should now use a colon equal sign, since this error variable was not declared before. Only app user was, but error wasn't. Therefore, we need this assignment operator here to declare error on the go. And then we can check if error is not equal to nil, and then do whatever we need to do. For example, return and exit out of the application, therefore, in this case, since continuing with these steps doesn't make sense if we have no user. I do want to output that error message though, therefore I will print the error. Now, if you try running this, you'll note that entering nothing here is pretty hard, because when you hit enter, nothing happens. It continues to wait for input, and you therefore have to manually stop the application by pressing Ctrl+C. And the reason for that is that scan doesn't automatically stop waiting for input when you enter a new line, so when you hit the enter key. You instead have to use scanln to make sure that hitting that enter key ends the input, so to say, so notifies Go of the fact that you're done entering a value. And with scanln used here, if we now run this again and we enter nothing for the first name, nothing for the last name, and then maybe something for the birth date, we get this error message and the application exits. And that's why this constructor pattern can be very useful, because it does not just allow you to outsource this creation logic, but it also makes it very easy to set up validation logic in a reusable way.